July 1st, 2025. In the desolate beauty of the Rio Hurtado Valley, Chile, a robotic telescope scans the night sky. An anomaly catches its eye, a fast-moving object unlike any asteroid or comet previously recorded. With a speed of 137,000 miles per hour, it's already inside Jupiter's orbit. Yet it originates from beyond our solar system. This discovery marks the third interstellar visitor we've ever detected, and it breaks every rule we know. On October 29th, 2025, when this comet, now named 3I Atlas, reaches its closest point to the Sun, perihelion, it stays a staggering 1.4 astronomical units out, 130 million miles just inside Mars's orbit, never crossing Earth's path. Most comets dive close, but 3I Atlas keeps its distance. Why? What does that distance tell us about where it's been and what it's made of? The Atlas Survey, a global network of robotic telescopes, first spotted 3I Atlas on July 1st. Located in Chile, Hawaii, and South Africa, the Atlas Survey scans the entire visible sky every 24 hours, hunting for near-Earth objects, NEOs, that might pose a threat to our planet. The Chilean site flagged object A11PL3Z, a faint, moving object. Follow-up observations from the Zwicky Transient Facility at Palomar Observatory in California confirmed the comet's presence, and pre-discovery images showed it had been in the frame since June 14, 2025, but too dim to trigger alerts. Orbital calculations started, and the speed of 61 kilometers per second, along with an eccentricity of 6.141, indicated an open-ended hyperbolic trajectory, the highest eccentricity ever measured for an interstellar object. More than 5 times the eccentricity of Oumuamua in 2017, nearly double the eccentricity of 2I Borisov in 2019. On July 2, 2025, the SETI Institute hosted a live broadcast, confirming 3I Atlas as interstellar. A team of astronomers, including Dr. Hyrus Simon Steele, Dr. James Davenport, Dr. Ariel Grykowski, Dr. Wale Farah, and C. Tai Chair in Allen Telescope Array Project scientist, discussed the implications of this discovery. The race was on for telescopes around the world to gather data before 3I Atlas disappeared behind the sun's glare in October. Hubble's Space Telescope captured 3I Atlas on July 21, 2025, 277 million miles from Earth. The image showed a teardrop-shaped coma, a cocoon of dust streaming off the nucleus. Stars streaked in the background because Hubble was tracking the comet's motion. The coma measured about 2 arc-seconds across at its brightest core, with a full width of 10 arc-seconds. Pre-discovering images from Vera Rubin showed the coma grew from 13,040 kilometers on June 21st to 18,760 kilometers on July 2nd. Active, outgassing. The nucleus itself, hidden inside the globe, estimates range from 440 meters to 5.6 kilometers in diameter. On August 6, 2025, James Webb Space Telescope turned its near-infrared spectrograph on 3I Atlas. The spectrum revealed carbon dioxide dominates, with a mixing ratio of carbon dioxide to water at 8:1. That's one of the highest carbon dioxide abundances ever recorded in a comet, especially at that distance from the Sun. The outgassing rate was 129 kilograms of carbon dioxide per second, 6.6 kilograms of water per second, and 14 kilograms of carbon monoxide per second. The comet was shedding mass fast, but it was shedding the wrong stuff in the wrong ratios. Solar system comets are water-rich, this one bleeds dry ice. 2 theories emerged to explain the high carbon dioxide abundance. The first suggested radiation exposure, with 3I Atlas wandering the galaxy for 7 to 14 billion years, bathed in radiation longer than Earth has existed. Water ice sublimates under radiation faster than carbon dioxide ice. Decades, centuries, millennia of particle bombardment could have boiled away the outer water layers. leaving a carbon dioxide-rich crust. The second theory suggested formation location, with 3I Atlas forming near or beyond the carbon dioxide frost line in its home system, naturally incorporating more carbon dioxide ice than water ice. On August 7th to 15th, 2025, NASA's Spherex Space Observatory observed 3I Atlas. Its images showed 3I Atlas as a point source, no resolved coma in most wavelengths. But at 426 micrometers, the carbon dioxide emission line, a symmetric cloud appeared. Brightness fell with projected distance to the power of -1.5, indicating a steep decline. The carbon dioxide density dropped with three-dimensional radius to the power of -2.5, suggesting a large nucleus, possibly 46 kilometers in diameter. On August 20th, 2025, the Very Large Telescope in Chile caught atomic nickel vapor in the coma. Nickel emission isn't rare in comets, but here's the twist: no iron. Nickel and iron typically appear together in comets because they come from the same parent minerals in the nucleus. Ratios are usually close to 1:1. 3I Atlas shows nickels to 4.6 grams per second, but 0 detectable iron. That's weird. One explanation is the chemical process releasing nickel from the nucleus operates differently here. Maybe the surface chemistry, altered by billions of years of radiation, traps iron but releases nickel. Maybe the parent minerals never contained much iron to begin with. On August 14th, 2025, same telescope, different molecule, cyanide gas, hydrogen cyanide specifically, first detected on August 14th, the concentration was 17.6 grams per second. By September 7th, when 3I Atlas was 233 astronomical units from the Sun, the James Clerk Maxwell telescope measured hydrogen cyanide production at 1.5 times 10 to the 25th molecules per second, roughly 0.5 kilograms per second. 1 week later, September 14th, it tripled 4.5 times 10 to the 25th molecules per second, 2 kilograms per second. The comet is ramping up, getting more active as it approaches perihelion. September 4th, 2025, Gemini South Telescope in Chile captured a deep image. The comet sits fixed in the center. Background stars streak because the telescope tracks the comet's motion. The coma looks puffy, reddish. The reddish color matches that of asteroids and outer solar system comets. It's caused by organic compounds called tholins, complex molecules formed when ultraviolet light or cosmic rays hit simpler ice as methane, ethane, nitrogen. Tholins give Pluto its reddish tint, the Coat Kuiper belt objects and the Coat 3I Atlas, suggesting the surface has been irradiated for a very long time. On September 2nd, 2025, the comet passed through a solar storm, a coronal mass ejection from the Sun. Solar plasma slams into the coma. Magnetic fields twist. For comparison, when a similar storm hit Comet Encke in 2007, the magnetic field collapsed, and the tail got severed. 3I Atlas, no reported damage, no tail break-off, it shrugs off the impact and keeps moving. That resilience hints at a dense, compact nucleus or a coma composition less vulnerable to magnetic disruption than typical water-rich comets. On October 2nd, 2025, 3I Atlas passed within 0.19 astronomical units of Mars, 28 million kilometers, 18 million miles. Mars orbiters prepared. ESA's Mars Express and ExoMars Trace Gas Orbiter turned their cameras toward the comet. Mars Express deployed its high-resolution stereo camera, Omega spectrometer, and SpyCam spectrometer. The Trace Gas Orbiter used its color and stereo surface imaging system, Cassis and Nomad spectrometer. NASA's Mars Reconnaissance Orbiter aimed high-rise, high-resolution imaging science experiment. These instruments are designed to photograph the Martian surface from a few hundred to 1,000 kilometers away. Now they're trying to image a dim comet 30 million kilometers distant. It's a long shot, but the comet might reach apparent magnitude 11 from Mars, faint but detectable. On October 29, 2025, perihelion 3I Atlas reached its closest point to the Sun, 1.36 astronomical units, 203 million kilometers, 126 million miles, just inside Mars's extra orbit. Mars averages 1.52 astronomical units from the Sun. Earth sits at 1 astronomical unit, 93 million miles. 3I Atlas never crosses Earth's orbit. It stays beyond us. Compare that to most comets. Halley's Comet, 0.59 astronomical units at perihelion. Comet Neowise in 2020, 0.29 astronomical units. Comet Encke, 0.34 astronomical units. Even 2, Borisov, the other interstellar comet, came within 2 astronomical units. 3, Atlas, keeps its distance. Why does it matter? Because perihelion distance dictates how much heat a comet receives and how violently it outgazes. Solar radiation intensity follows the inverse square law. At 1 astronomical unit, Earth receives 1,361 watts per square meter. At 1.4 astronomical units, that drops to about 690 watts per square meter. Roughly half, less heat means less sublimation. The water ice needs more energy to turn to vapor than carbon dioxide ice. That explains the 8:1 carbon dioxide to water ratio in the coma. The comet isn't hot enough to release much water. If it had plunged closer, say 0.5 astronomical units, the nucleus would have heated to several hundred degrees Celsius. Water would have gushed. The coma would have looked completely different. But at 1.4 astronomical units, the surface stays cold enough that only the most volatile ice is escaping easily. Carbon dioxide, carbon monoxide, hydrogen cyanide, water remains mostly locked. This perihelion distance also reveals something about the comet's past. If 3I Atlas had made close passes around its parent star before ejection, the outer layers would have been stripped. We'd see a bare, rocky core or a water-dominated interior exposed. Instead, we see a comet rich in carbon dioxide, a far-orbit volatile. That suggests 3I Atlas never got cooked by its home star. It formed in the cold outer regions of its protoplanetary disk, beyond 10 astronomical units, where carbon dioxide freezes solid. It stayed out there, accumulating ice and dust until something kicked. It loose, then it wandered. For billions of years, never falling into another star, never heating up, preserving the chemistry from its birth. On October 21st, 2025, solar conjunction, from Earth's perspective, 3I Atlas passes directly behind the Sun. Solar elongation, the angular separation between the comet and the Sun in our sky, drops below 30 degrees from October 1st to November 9th. Impossible to observe from Earth. The Sun's glare drowns it out. Even Hubble and Webb can't point that close to the Sun without risking damage to their instruments. For 5 weeks we lose sight of it. But spacecraft farther out keep watching. NASA's Psyche mission en route to asteroid 16 Psyche in the main belt passes within 0.4 astronomical units of 3I Atlas on September 4th. No public images released yet. ESA's JUICE spacecraft, Jupiter Icy Moons, explore currently near the Sun on its long journey to Jupiter. Plans observations between November the 2nd and 25th. Right after perihelion, when the comet should be at peak activity, JUICE will be in the best position to see the comet's tail and measure outgassing rates when the nucleus is hottest. The timing of perihelion matters for another reason. At 1.4 astronomical units, 3I Atlas is moving at its maximum speed, 68 kilometers per second, with respect to the Sun. That's close to the escape velocity at that distance. Escape velocity from the solar system depends on how far you are from the Sun. At Mercury's orbit, 0.4 astronomical units. Escape velocity is 68 kilometers per second. At Earth's orbit, 1 astronomical unit is 42 kilometers per second. At Mars' orbit are 1.5 astronomical units. It's 24 kilometers per second. 3I Atlas at 1.36 astronomical units is travelling at exactly the speed needed to break free from the Sun's gravity. It's not slowing down, it's not getting captured, it's passing through. That trajectory coming in fast, swinging past the Sun at a safe distance, heading back out without slowing, looks like a gravitational assist in reverse. Spacecraft used gravitational assists to steal momentum from planets and accelerate. 3I Atlas is doing the opposite, stealing a tiny bit of the Sun's momentum to alter its path slightly while maintaining its interstellar speed. After perihelion, it will continue moving through the inner solar system, passing 0.65 astronomical units from Venus on November 3rd, 1.8 astronomical units from Earth on December 19th, and 0.36 astronomical units from Jupiter on March 16th, 2026. Then it exits back into interstellar space, never to return. On November 10th, 2025, silence breaks. For 40 days and 40 nights, 3I Atlas has been lost in the Sun's glare, a ghost in the machine. From Earth's perspective, solar conjunction rendered it invisible. A calculated blackout period where humanity's most powerful eyes were forced to shut. But 162 million miles away, on a trajectory that will not reach Jupiter for another 3 years, the European Space Agency's JUICE spacecraft had a front-row seat. Its data, trickling back across the solar system at the speed of light, begins to paint a picture of the comet's trial by fire. The first telemetry packets arrive at the European Space Operations Center in Darmstadt, Germany. The science teams, running on caffeine and adrenaline for over a month, finally see what happened when 3I Atlas met the Sun. It didn't just pass perihelion, it detonated. On October 29th at 11:44 UTC, precisely as predicted, the comet reached its closest point to the Sun, 136 astronomical units. At this distance, the surface temperature of the nucleus, warmed by 690 watts of solar energy per square meter, reached a critical threshold. The JUICE spacecraft's ultraviolet spectrograph, or UVS ice, saw it happen in real time. The instrument, designed to study the auroras on Jupiter's icy moons, registered a sudden cataclysmic spike in hydroxyl radicals, the telltale signature of water vapor being ripped apart by solar radiation. In the space of 90 minutes, the water outgassing rate exploded, increasing from a mere 6.6 kilograms per second measured in August to an astonishing 4,500 kilograms per second. That's a 700-fold increase. The carbon dioxide output also surged, but only by a factor of 10 to 1,290 kilograms per second. The famous 8-to-1 ratio of carbon dioxide to water had violently inverted. For a brief, brilliant period, 3I Atlas became a water-rich comet after all. Dr. Anja Klein, lead scientist for the UVS instrument at the Royal Belgian Institute for Space Astronomy, presented the preliminary findings in an emergency ESA press conference on November 12th. Her face, projected on screens worldwide, was a mask of exhausted elation. "We were witnessing a process of exfoliation," she explained, her voice echoing in the packed auditorium. The comet's outer layer, the crust that had been bombarded by cosmic rays for billions of years, was rich in carbon dioxide and complex organics. It acted as an insulating blanket. As solar heating intensified at perihelion, the pressure of sublimating water ice trapped beneath this crust built up. It was a geological time bomb. At perihelion, the pressure overcame the tensile strength of the crust. The section of the nucleus, estimated to be at least 2 square kilometers in area, violently ruptured and was blown off into space. The event, now designated Outburst Alpha, was more than just a chemical release. Juicist Janus camera, a high-resolution optical system, captured a sequence of images that stunned the world. The faint, teardrop-shaped coma transformed. A brilliant, fan-shaped spray of dust and ice erupted from the nucleus, expanding outward at over 500 meters per second. The new material caught the sunlight, and the comet's total brightness, its apparent magnitude, jumped from a predicted 14 to an observed 7.2. For a few hours, 3I Atlas was nearly 50 times brighter than anticipated, briefly becoming visible to well-equipped amateur astronomers on Earth as it began to creep out from behind the sun in the pre-dawn sky. The images from Janus, though taken from a distance of over 1.1 astronomical units, were sharp enough to resolve not a single point of light. But a cluster, the nucleus, had fractured. The single object that entered the inner solar system was now at least 3. The primary fragment, designated 3I Atlas A, remained the largest. 2 smaller pieces, B and C, were seen separating from the main body, each trailing its own nascent coma. The 46-kilometer diameter nucleus proposed by Avilobi was definitively ruled out. A body that large would not have succumbed to such a dramatic rotational breakup. The Hubble-based estimates of a smaller, sub-6-kilometer nucleus were proven correct. What we were seeing was a rubble pile, a loosely consolidated agglomerate of ice and rock, barely held together by its own feeble gravity, that had finally surrendered to the sun's tidal forces and thermal stress. This comet wasn't a solid rock. It was a cosmic snowball that had cracked under pressure. On December 19, 2025, 3I Atlas A and its children make their closest approach to Earth. They are a disappointment for stargazers, passing at a safe distance of 1.8 astronomical units, 167 million miles. They are too far, too dim, and too diffuse for naked eye observation. But for the world's great observatories, this is the moment of truth. The James Webb Space Telescope. Its instruments, now cooled and recalibrated after the long solar avoidance period, fix its golden eye on the debris field. The near-infrared spectrograph, the same instrument that first revealed the comet's carbon dioxide-rich nature, now tastes the fresh material excavated from its core. The spectrum is a revelation. The water is there in abundance, but it is chemically old. The ratio of deuterium, a heavy isotope of hydrogen, to normal hydrogen is one of the highest ever measured in a solar system body, 3 times that of Earth's oceans. This D to H ratio is a fossil fingerprint, a clue to where and when the water ice originally formed. High ratios are characteristic of water that condensed in extremely cold, impassioned interstellar environments long before a star ignited. 3I Atlas was not just from another star system. It was composed of primordial material that predated its own parent star. It was a frozen piece of the very interstellar cloud from which its home system was born. The mystery of the nickel without iron also finds its resolution in the fresh ejecta. The Very Large Telescope, using its espresso spectrograph, detects faint signatures of iron carbonyl in the expanding cloud from Outburst Alpha. Iron carbonyl is a volatile compound formed when carbon monoxide gas reacts with iron-bearing minerals at very low temperatures. It sublimates easily. The original theory was half right. The comet's surface chemistry, altered by radiation, had indeed played a role. Over eons, the iron on the surface had been locked into less volatile minerals by cosmic ray bombardment. The nickel, however, remained in a more pristine, easily vaporized form, but below that irradiated crust, in the comet's protected interior, the iron existed as iron carbonyl. When the outburst exposed this virgin material to sunlight for the first time in billions of years, the iron carbonyl vaporized instantly, releasing atomic iron into the coma, but only in the immediate aftermath of the fragmentation. The initial observations had simply missed the window. "We weren't seeing a lack of iron," explained Dr. Thomas Puzia in a follow-up interview. "We were seeing a comet with layers, an irradiated iron-poor skin, and a volatile iron-rich heart. We just needed the sun to peel it open for us." February 15th, 2026. The data from Mars finally arrives. The full-down link from the Mars Reconnaissance Orbiter, ExoMars Trace Gas Orbiter, and Mars Express had been queued for months, waiting for favorable antenna positioning. The high-rise camera on the MRO, which had aged the comet on October 2nd, 2025, provides the most crucial piece of evidence. The images, taken just 27 days before perihelion, show a single, slightly elongated nucleus. A series of advanced deconvolution algorithms run on supercomputers at the Jet Propulsion Laboratory produce a shape model. The nucleus was a contact binary, two smaller bodies gently fused together, looking like a cosmic rubber duck, about 4.2 kilometers long and 2.1 kilometers wide at its thickest point. The model reveals deep fractures and fissures along the neck connecting the two lobes. This was the weak point. This is where the rotational stress, amplified by the violent outgassing, tore the comet apart. The outburst wasn't random. It was a structural failure at a pre-existing fault line. The comet had carried the seeds of its own destruction for its entire journey across the galaxy. March 16th, 2026, the caravan of fragments now spread out over 500,000 miles. The sweeps past Jupiter. The gas giant, 5.2 astronomical units from the Sun, is a distant spectator, but its immense gravity gives the fragments one final, gentle nudge. This gravitational assist, minuscule as it is, refines the trajectory calculations to an unprecedented degree of precision. Teams at the Minor Planet Center issue their final definitive orbital solution. The incoming eccentricity was 6.141. The outgoing eccentricity is 6.138. It gave a tiny fraction of its cosmic velocity to the Sun, but its destiny was never in doubt. It is leaving, and it is never coming back. The Vera Rubin Observatory in Chile, now in its second year of full science operations, tracks the fading fragments as they recede into the darkness beyond Saturn. Its legacy, the survey of space and time, is designed to find tens of thousands of new comets and asteroids, and it will undoubtedly find the next interstellar visitors, 4I, 5I, and 6I. But 3I Atlas will be remembered as the one that put on a show. It didn't just fly by, it performed. It shed its disguise, revealed its ancient heart, and broke itself apart for science. By July 2027, 2 years after its discovery, a scientific consensus has formed, published in a multi-authored review paper in Nature Astronomy. 3I Atlas was born in the cold outer disk of a young sun in the Milky Way's thick disk, perhaps 9 billion years ago. It formed beyond the carbon dioxide frost line, incorporating ancient Yikaseish by Carnem Dura, deuterium-rich interstellar ice. It was a contact binary, the result of a gentle merger of two smaller planetesimals in the chaotic early days of its home system, before it ever had a chance to fall inward toward its star. A gravitational encounter, likely with a gas giant planet migrating through the system, ejected it at a tremendous speed. For billions of years it drifted through the void. Its surface was cooked by galactic cosmic rays, creating a reddish, organic-rich crust of tholins and boiling away the most accessible water ice, leaving a concentrated layer of carbon dioxide. This crust protected its primordial interior. Its trajectory, by pure chance, brought it into our solar system. Its high speed and distant perihelion were not unusual for an object on such a random walk. It was never destined for a fiery plunge, but the modest heating it did receive was enough to trigger the catastrophic failure of its structurally weak bilobe nucleus. The outburst we witnessed was the comet's first and last act of solar-induced activity. It was a truly pristine object, a time capsule from another world, and we were simply lucky enough to be there when it opened. The debate about artificiality, briefly stoked by the initial high-speed anomaly, is quietly settled. Dr. Loeb himself, in a blog post titled "A Wonderful Natural Death," concedes that the fragmentation event is overwhelmingly characteristic of a natural comet. While we must always remain open to extraordinary possibilities, he writes, the self-destruction of 3I Atlas provides a powerful, albeit spectacular, Occam's razor. It behaved exactly as a loosely bound, irradiated ruffle pile should. The alien was not its origin, but its chemistry. As the fragments of 3I Atlas coast silently toward the Oort cloud, too faint to ever be seen again, they leave behind a transformed field of study. The paradigm has shifted. Interstellar objects are not just curiosities, they are messengers. There are free samples of planetary building blocks from across the galaxy, delivered to our doorstep. We learn that the chemistry of other solar systems can be wildly different, with varying ratios of water, carbon, and nickel. We learned that these objects can carry primordial ice that predates their own stars, and we learned that they can be fragile, breaking apart and revealing their secrets if they venture even moderately close to our sun. The next one is already out there, hurtling through the dark at 100,000 miles per hour, and this time, thanks to the violent, revealing spectacle of 3I Atlas, we'll be ready. We'll know what to look for. We'll be waiting to see what new rules it breaks.